Tech Nuggets, NAT. NAT stands for Network Address Translation. It's designed to solve the problem of what happens when we run out of real globally routable addresses. When you do the math, you'll realize that there's only a finite number of globally routable IP addresses, and there aren't nearly enough for all the devices that are out there in the world. And as many of my colleagues are immediately to jump to that, yes, there is IPv6, which is a solution to the problem and has many more bits in the addresses and will solve that problem. In the meantime, we have a number of devices and, in fact, large pieces of infrastructure that are running on IP version 4, where we're running out of addresses. And that's right now the problem that we're struggling with and why we're talking about NAT. NAT is a solution to this problem, but it has some issues that go with it that make it not realistically long-term viable. NAT is terribly inefficient. The CPU overhead, the memory overhead to do NATing is very, very inefficient. And it's generally used, NATing is generally used at the enterprise level and down. So it's not used on the core of the internet. It's not used out in the wide world. There are instances of it. I believe China is this way currently, as of 2019, where they only have a small allocation of real addresses, and for the most part, their entire country is NATed behind several large firewalls and several large NATs out to the rest of the globally routable internet. NAT is a process where on one side of a router, we use our one real address. And in the case of like I'm a Spectrum cable modem user, I will get one real address assigned to my cable modem, and then I will need to do something with that. I can plug one machine in, or I can plug in a NAT. It will use the one IP address, and then behind the NAT, it will hand out a variety of reserved address. RFC 1819, I believe it is. 1918, excuse me, is the RFC for it, where there's some address space that's never used. It's never handed out in the global world. You've probably used it and not even realized it. But your NAT device will hand out some of that address space or will allow use of that address space behind it. And it will translate between requests that come in on these IP addresses that are reserved and the one address that's out. And it will keep a state table of who made what recalls and requests and go through that process. And that's why I say it's very inefficient, because there's a bunch of CPU and memory that goes into keeping the state table and rewriting these packets as they go back and forth, as every single packet that's sent by a client is rewritten by the NAT before it can go out. So we're going to do a GNS3 practical demo in Wireshark so that we can see the packets going back and forth. We'll set it up and use it in Voyos, our demos, so it'll be a quick, easy kind of setup. There are much more complicated and involved settings that go with this that will allow you more options and more flexibility. But for our case, Voyos will kind of get us off the ground and give us the basic gist of what's going on. All right, so the first step here is we're going to set up GNS3 and we're going to lay out our basic network, and we'll talk a little about what that means as I get the pieces laid out. So we're going to grab a cloud, drop that out there, and we're going to grab a Voyos, drop it out there, and we're going to grab a switch, drop it out there, and we'll grab a VPCS, put it out there, and we can close all that up. So I'm going to move all of my little parts around so that they're easier to see, and we'll leave a bunch of space for command windows and Wiresharking and stuff like that when we want to get to it. So I'm going to kind of scrunch it all over here so that we can see it all and that kind of thing. I think we'll be okay with that. Connect it all together. So when I go to use my cloud object, cloud objects are different than the NAT object. The NAT object is going to NAT for us. We don't have to do anything. So we're going to use a cloud object, which in our case is going to give us access to our VM's native Ethernet cards. And in our case, we're going to use ENS 160, which will give us a connection directly to the Ethernet card. And we're going to bring it down to Voyos, and we're going to connect that to Ethernet 0. So connection there. We will then go from Voyos 1 on Ether 1 to the Ethernet switch, and we can kind of pick any. This is just a 8-port switch, so we pick anything we want from here. And we will go from there to the VPCS, which only has one Ethernet card. This gets our basic network set up and ready to go. All right, so we've got all of our objects out here, And none of them are started, right? Voyos isn't running, VPCS isn't running, so we'll reach up and hit the start button. And that'll bring everything to life. And VPCS is stupid easy, right? It just sort of jumps up and is ready to go. Voyos, on the other hand, is a real Debian kernel and will sit and grind and whiz and whir, and you saw the console there a second ago, and I'll bring it back. There's our VPCS kernel, or our console, excuse me, and we'll put that down there so we can see it. And we'll hop back here, and we'll have a little look at our Voyos console. Actually, I think I'm going to swap sides on those. And it will take quite a while to boot. So I will pause this so we can have a little time compression action. And when it's all done, I will restart the recording. Okay, so we can see that Voyos has sort of heaved itself into the air here and is more or less ready to go. Let's talk real briefly about the VPCS and kind of how to get information in and out of it and that kind of stuff. So you can always hit question mark and you'll get this big long list of somewhat useful commands that if you don't sit down and play with, you won't understand what they all are. So I highly recommend you sit down and play with them for a little bit. The show command is generally speaking quite useful, as just typing show will give you basic things like what's my IP address and MAC address and stuff like that. But you can also do show IP, which will give you a little bit more information in later videos or earlier videos, depending on which order you're watching them in. In DHCP, you'll see lease times and gateways and options and things like that. But right now, our VPCS is completely unconfigured. But we can do some of that kind of configuration by doing this kind of stuff, where we can give it an address and a mask and that kind of stuff. And we'll, in fact, do that as we go along through this. So let's jump back to our Voyos box. And note right down here where it says write control, as I click on it, it will light up green, which means it seized my mouse. This is a function of being a virtualized box. You'll notice I don't get my mouse back until I actually click on the keyboard on the right control button, and it gives me my mouse back. So make sure that if it seizes it, you don't go crazy trying to get it all back, because it'll drive you nutty. I always seem to get caught by that one. All right, so let's log in. This is going to use a username and password that you have not used unless you're an ITS student. So ITS class, and we will give you the password in class, or you will know the password, as I'm not going to put it out on YouTube. So there we go. We get logged in as ITS class, and you're sitting at a Voyos terminal. So we're going to go into config mode. You should have seen something about the config mode in our earlier Voyos videos, which will put us in config mode. So at this point, we can do a show, and we can see that ETH0 has come up and is configured for DHCP. Again, something we'll cover in another topic, but it should give us an outside world address. So if we were to go do show IP, it's just IP. It's just IPA, excuse me. And we can see that we have an IP on ETH0. It is 10.101.1.100. So we can see it's right there. And so that means we can do things like, ping, and it'll ping. So we have connectivity to the outside world provided to us through the cloud, and we've set our Voyos machine up to do DHCP automatically. That will do very little for our VPCS, which is what we want to give some connectivity to. Right now, VPCS is set up on a closed LAN and needs to use Voyos to get out. And to do that, we're going to give it some address space and set up a NAT on it. So in order to do that, it's actually rather simple. We're going to go in and say set NAT source rule 100. We can have multiple NATs. They each need to be their own rule. And we'll say outbound interface ETH0, since our outbound traffic is going to go out through that Ethernet card. So we will also say set NAT source rule 100. Like all the commands will start this way. Source address, and we're going to give it a network. And in our case, we're going to 192.168.1.0/24. So what we're saying is we're going to NAT anything that shows up on my interfaces in that range. We're going to NAT out and back. And set NAT source rule 100 translation. We're going to translate it back and forth. And this masquerade command is going to say, don't show the outside world that kind of stuff. If you're interested in more of the technical nerdyism of what does masquerade do, have a look at the Voyos guide. There's a very nice paragraph that'll give it a quick description. But the short version is it will masquerade and make the outside world believe that everything that's happening on the inside of the NAT is really what's the outside. You know, the Voyos is actually doing it all. That's what masquerade would mean. So in this case, we can do a show. If we go down, we can see that it's added a section there with all the pluses, and we can see that it's set it up. So we'll hit commit, and it will commit all our changes. So as I was going along through this, I realized that we had sort of skipped a step. We hadn't set up the interface on ETH1. That's the side facing the VPCS. So we will need to go in and configure that. Ethernet 1 address, which should be 2168.1.254, right? This is the default gateway out of the network. So it will need to be the last usable address in the range. 192.168 is the RFC 1918 that I was talking about earlier. It's one of the ranges. I believe there's 3 of them. 192.168.0.0/16 is set aside. It is non-routable space. Normal internet routers will just drop the packets if they see it. That means we can use it in NATed space and use it in closed LAN environments, and if the packets get loose, they just get dropped. They don't run away off the internet, causing all sorts of trouble. There are several others. 10.0.0.0/8, it's very large, is one that gets used. Our university is using it, and we're natting the entire university behind some 10 addresses. There are several others that get used, sometimes as self-assigned and sometimes in other places. If you're interested, go read the entire RFC, and they will lay all that out. Of course, there's other places on the internet that will tell you that. So let's commit our changes, which should bring up ETH1 with an IP address. And I was over here playing with this, trying to understand what I wanted to do to set it up. So I've crafted an IP command here that should set the VPCS's IP address to 192.168.1.10 and give it a gateway of the Voyos box. It's going to go out, it's going to check for duplicate addresses, and then it'll say, yeah, okay, we can have that one. We should be able to ping our gateway. Right? So packets are going back and forth. I can ping my gateway. Life is good. So at this point, we've got VPCS set up with an IP address that's on the 192.168 side. We've got Voyos's Ethernet set up, right? It's got IP addresses that it's getting from cloud, which is internet at this point, via DHCP. And it's also got its ETH1 set up as the gateway for the LAN side. And, we've configured the NAT with the 3 lines that we put in. At this point, if we've done it all right and I suppose lived a good life and have good karma, things should work, just the way we expect them to. So let's give it a try. 8.8.8.8 is, out to the internet. And there we go. We can see the packets going out. They're coming back. Voyos is doing the magic it should be doing. Next, we're going to take a quick look at the actual packets. We'll start 2 different Wiresharks on either side of Voyos so that we can see the packets leave on one side from the VPCS, and we'll see the 192.168 address, and then they'll leave out through Voyos, and we'll see that it's got a very different address. The Voyos ETH0 side is using 10 addresses because that's what we use in our lab environment. So we'll see 10 addresses on the outbound side toward cloud. And we should be able to square up those pings as they go back and forth and watch NAT do its work. All right, so we talked a little earlier about Wireshark in GNS3, and it's a little bit of a different animal than it is in the lab context where we're using it. And the reason for that is there's a disconnect between the piece of software that's actually collecting the packets and Wireshark that's displaying the packets. So we need to be kind of careful when we do this kind of stuff. We can get into a situation where Wireshark will crash and do some weird things. So we just want to be cognizant and understanding of that, what's going on with that. So the first thing we're going to do is right-click on our link, and we're going to say Start a Capture. This is going to start the piece of software. Again, if we've lived a good life, the Start Capture Visualization program should start Wireshark, which should show it to us. It might. In this case, it does. That's great. Sometimes it will not, and that can be very frustrating. We'll go ahead and do that. It's capturing as we speak. There's just not much going on. On the other link, we will do the same thing, and we will say Start a Capture. And we'll say the same thing. It should start a second copy. Looks like it is this time. That's great. And you can always tell by looking at the top. Whoa, there's lots going on there. And we're going to filter that. So in just a second here. You can see on one side we've got a very quiet network, and on the other side we have a very noisy network. That's one of the reasons we stick up these kind of networks, so that we can have a quiet spot to work in. So we're going to be doing pinging. So all we're really going to do is do a display filter on ping. So we come up and we say ping, and oh no, we won't need ping. We want ICMP, CMP, because that's what ping is, generally speaking. And right now we're not seeing any of that. So let's go back and pull up our VPCS console and look at some pings. All right, so we should see 5 pings, right? And we can see the pings are going out. From here, we can see that ICMP. Right, there we go. So now we can see there's pings going out, and they match up pretty closely, right? Timestamps, of course, don't match up because I started them at different times, but you can see our, 1.10. This is our VPCS sending out 8.8.8.8 off to where we want to see. And it's getting responses back, request and replies and request and replies, and they're coming back. What we also see here is 10.101.100 is our Voyos box on the WAN side, the side that's facing cloud, our internet cloud, and it's doing the requesting as it goes by. And we didn't type that at the console, so we can see the network address translation going on. As we look at both sides of Voyos, we can see that happening as it goes back and forth. This is pretty much it for NAT. NAT is a really simple widget. It's not super efficient on RAM or CPU, but there's not a lot to it in terms of get it set up and make it work. There are a few knobs and levers, so to speak, that you can play with, but for the most part, it does its job, and it does it pretty okay. On small networks, home networks, even larger enterprise networks like the university, it does an okay job. Most clients never know the difference. Most operating systems these days have been, coded in such a way that they're very familiar with NAT as a process, and so they tend not to break. Browsers don't break, that kind of stuff. We'll come back with more tech nuggets in the future, so stay tuned. Hope you like this one. Have a nice one.